All right, so this video, I'm going to do 11 problems. I'm going to do them 5 days in a row. And I hope that if you do them 5 days in a row, that by day 5, and you don't have to pause the video, you can just watch. But if you get that repetitiveness 5 days in a row, I firmly believe that many of the problems that I'm about to do will be handled by you fairly well. The more times you do a problem, the more you see about it, the more you learn about it. And I've got a message down below. Switch to a different microphone. I don't need to switch to a different microphone. We'll see how this goes. So what I'm going to do is I'm going to take my nice science card around so you can look at the problems. And the first problem, let's get a little bit higher here. All right, going to solve that inequality graphically. And then we're going to get 1 period of the sine function, 1 period of the cosine function. Going to look at domain for this particular problem. And how about going after the domain quickly and easily? Coming around here, all these problems are on the board. We've got sketch, rational functions. There's plenty of YouTube videos that will help you learn how to do that, but I'll do a problem here. Different type of rational function, which is a fancy name for fractions. Piecewise, sketching an absolute value, writing it as a piecewise, solving it for a given y value, and inequality as well. A few more problems. Name that tune. So we got a couple of ways of writing this sinusoid. We're going to look at the rules of logarithms. We're going to find the value, the approximate value of the ln of 25 halves organically, and then we'll parallel it with the rules of logs, which is a quicker and easier way of getting those answers. But we want to make sure, or I want to make sure you understand what you're doing and how. Going to do a quick sketch of a log, and we're going to get good at evaluating sine and cosine triangles in the unit circle. All right, so now I got to make my way back to the first problem. Now you kind of have a sense of what order these problems are done in. So if you feel like, oh, I can do that problem now in my sleep, you might move around a little bit. Otherwise, just watch the 5 problems as I go around and do them. All right, so what do I see here? I see different types of exponents, odd and even. And I talked about that in previous videos. So I am going to put a 0 in that 0. I'm going to put a dot because it's an even exponent, so I won't get a sign change. At 2, I'm going to get a sign change. And at -4, I'm not. Oh, this is going to be a real quick one. Okay, so I only have 1 sign change. So I'm going to look at whether I'm bigger or less than 0 when I put a number bigger than 2 in. Bigger than 2, well, this is always positive. That's going to be positive, and that's going to be positive. Looks like I've got a cubic root. So that's kind of a cubic root look. A quadratic root, and a 4th degree, which stays near 0 longer. Not the best graph, but now I can answer the question. When am I greater than or equal to 0? Well, I'm equal to 0 at -4. I'm equal to 0 at 0. And I'm equal to 0 at 2. And I'm certainly bigger for all x values heading to infinity. All right, so I captured all of that. 1 period for the sine function. Okay, I guess you can see that well. Sine function measures the y values in the unit circle of triangles drawn. So that y value is positive, and as I move around the circle from 0 radians, I go to a maximum of 1. So from 0 to 1, going up, which means I'm coming back down to the same height over here that I started at, midline of 0. And then I do the same thing with the negatives. And so I can put a little midline, little line, so I can get my range. My range of the sine function is 1 to -1, which gets tripled. 3 to -3, 20 being the center, 23 being the max, 17 being the min. And I know that that location is 0 radius lengths, So when does 2x minus 10 equal 0? Well, that's easy enough, 5. So 5 is going to get me 20. Right, that's going to be on the graph. And there's shortcuts to what I'm doing, but I'm not going to take one with you yet. 2x minus 10 equals 2 pi. And so therefore we have 2x equals 10 plus 2 pi. I prefer to write it that way. And then if we divide by 2, we end up back at 20 at 5 plus pi, comma 20. Now that means that 5 plus pi over 2 is easy to see what that is. 5 plus pi over 4 is easy to see, getting us 23. Okay, and because it's the first video, I will actually, now I'm not going to do anything other than just get you a quick answer here, because we're doing it 5 days in. All right, cosine curve. Well, cosine measures the x values, and that x value is a max, right? If I'm drawing triangles, no height, but that width is 1 unit long, so is the hypotenuse. So therefore, I want x minus 3 over 4 to equal 0, and I want x minus 3 over 4 to equal 2 pi. The start of the revolution, the end of the revolution, depending upon who you're for. All right, so x equals 3, and maximums occur from here to here. That's 1 period of the cosine curve. The middle is still the constant, and the constant is 2. And the amplitude of 5 means I'm going up to 7, and I'm going down to negative 3. Yep, that looks good. So 7, what produces a 7? An x value of 0, so 3 gets us 7. And then I got 3 plus 8 pi. 8 pi. Okay, I'm starting from 3. And so the period of this is 8 pi. Because I'm ending up at 3 plus 8 pi. Now, why is it 8 pi, you say? Because you're dividing by 4. 8 pi divided by 4. Yeah, I mean, put 3 plus 8 pi in here. You can see what happens to the 3's, and 8 pi divided by 4 is 2 pi, which is 1 period. All right, so where am I? I got control of this thing. So this is 3 plus pi over 4. 4 pi, excuse me. And that's going to get me negative 3. In other words, I can start putting in values based on the symmetry. Next problem, domain 4. Well, there's only 3 real algorithms that you have to worry about for domain at the algebra 2 level. And that is square roots. We got a problem with square roots. We can't have negatives. We got a problem with division. We can't have division by 0. In fact, you know, Billy, Mrs. Sheehan's class in 1876, told her that 7 divided by 0 was 0. And she said, no, it's not. That's where the null set came from. I've told that story before. Could have been a different teacher and a different student. So we got a problem here, division by 0. We got a problem here, can't have any negatives. And the other one you have to be careful of is logarithms, right? Logarithms, the parentheses, whatever's in the parentheses, it better be bigger than 0. Because if it's not bigger than 0, then you're not going the inverse of growth and decay. Yep, can't have negative bacteria. No. All right, so we make a number line, we put the critical numbers, -5, critical, +7, critical. And you also have to worry about this one in particular, or any function that might produce zeros in the denominator. And I got news for you. Log 1 makes 0. You make that parentheses 1, you got a problem. All right, so let's just check. Can I use the number -10? -10 plus 5 is the square root of -5, and no, I can't use that, so no. Can I use -5? Well, that becomes 0 over -12, and yes, that equals 0 because -12 times 0 is 0. So yes, I can use -5. Can I use numbers between -5 and 7? Let's pick 0. Square root of 5 divided by 7, -7. Calculator's going to do that, so check. Can I use the number 7? No. Can't use the number 7. That would be division by 0. Can I use numbers bigger than 7? Yes. So what's the domain of this? -5 works all the way to 7, which does not. But then we pick up again at 7 and we go to infinity, and that's the domain of this problem. We'll do the same thing with a new algorithm tomorrow. Every day, we go through this once. These are the newer problems that you might have problems with. So, what am I looking for? The y-intercept. Well, that's a piece of cake. I just plug 0 in and get -3/8. 0 gets me -3/8. Check. X-intercept. Well, I know functions, fractions have a numerator and denominator. And if they're going to equal 0, then the numerator has to equal 0 times the denominator, which means that I'm looking for when the numerator is 0. That's not hard. We'll call that, let's put that on this side, 0. I don't know where to hide this. Let's put it over here. 0, -3/8. All right, I'll just put a dot here, right? X-intercept, x equals 3. So that would be about here, maybe. End behavior. End behavior is when you put a big number. So let's put 1,000. Let's just put 100. 100 minus 3, 97. 208. Do you have a feeling for the size of that fraction? Do you see that it's close to 100 divided by 200? And if I put bigger numbers in, I'm going to get closer to this, closer and closer. Looks to me like I'm heading to a half. So that's one of the equations of an asymptote. What's the other one? X equals -4. Well, I think I got this graph. There's only one x-intercept. It's the only time you can cross the x-axis, and I know it's going to end up over here because if I put a -100, a minus divided by a minus brings me back to a half, so there's your graph. And these are going to take a while to learn the little ins and outs. What's the limit as x goes to -4? Doesn't exist, because as I come to -4, I can't make up my mind whether I'm heading north or south. I got to be going to the same location in order to talk about a y value. And limits are really y values. No, but what happened if I came in from the right? Well, from the right, oh, I'm heading to -infinity. And then you say, what would happen if I come in from the left? From the left. Woo. What's it mean to come in from the left? Well, here's -4. Here's -10. Where is -10 compared to -4? It's left of -4. So if I come in from the left, -9, -8, -4.001, it's useful to see what happens when you put -4.001 in here. You get something like -4 minus 3, -7 divided by -0.02. Yeah, that little critter fits into that a lot of positive times. Boom. So from the left, positive infinity, from the right, negative. Boom. Together, doesn't exist. Okay, now, I'm not asking you to learn that on the spot, but if you look at a video 5 days in a row, what I'm talking about 5 days from now might have a whole lot of different meaning. All right, so I'm going to use what's on the left here. If I had a eraser, you would think that I would know enough. I think they took the erasers out of here. All right, so I'm going to just erase with the old here. All right. Oh, when was it greater than 0? Yeah, well, let's talk about that. So just looking at the graph now, can we see when it's greater than 0? Well, it's greater than 0 from -infinity to -4. -infinity to -4. And then -4 is undefined. And it's certainly negative until I get to this x value, which we said was 3. Okay, so therefore, 3 to infinity answers that question. So now I'm just going to graph this one over here, and I'll put some more stuff on the board during the second video. I'm just going to go after this critter right now. But in order to do it, I got to factor x squared minus 4, which is x plus 2, x minus 2. What does the denominator give me? 2 asymptotic behaviors, one at +2 and one at -2. Y-intercept's easy to find. It would have been easier if I left it as 3 over -4. 3, so 0 gets me -3/4. I can still see it throwing a 0 in. And behavior, I know this is going to 0 because I have x plus 3 is to the first power and x squared minus 4 is to the second. And when the denominator has a bigger power in it than the numerator, then this tends to dominate. When you start putting big numbers in, like 100, when I put 100 in, I'm close to 100 in the numerator. When I square 100, I've got 4 zeros. It is just outnumbering the numerator, which means the fraction's getting small. And if I add a 0 and add 2 zeros there, and add a 0 and add 2 zeros there, it's getting smaller. Okay, so y equals 0 is an asymptote on the right. It's going to be the same thing over here on the left. We'll examine that further as we go along. I can see -3. -3's here. So this is going to be a little funky over here. You'll have to check it out carefully as we go forward. What else? X-intercept, y-intercept, asymptotes. We got our asymptotes. We're ready to draw. All right, so I put a number in bigger than 2. Bigger than 2 is a positive numerator. It's a positive, and it's a positive. I have a positive answer, so my graph's going to look like this. The bigger I get, the smaller I get, little inverse operation. I'm going to get something like this because there cannot be any more x-intercepts than this. And because that's an x-intercept, I got to be real careful over here. So I'm going to put in a -1,000,000. So I got a -1,000,000 over a -1,000,000 times a -1,000,000. That's a negative number. That means I'm heading to 0 from below. So that means this thing had to come down here and come back up. And that's hard to see. You know, I didn't anticipate that happening to you here, but let's take a number very close to -2. -2.5. -2.5 plus 3 is a half. 2.5 is 5 halves times 2.5, -2.5, excuse me, -2.5 plus 2. Oh, brain is very slow. It's -1/2. -1/2. Oh, almost made this error. -2.5 minus 2 is -5 halves. Okay, I got 2 negatives, 1 positive, which means I get a positive answer. Okay, so somewhere in here is a positive answer. And I know the rest are negative, and I know I'm going to 0. And the longer I go towards -infinity, the closer to 0 I get. So there is a local minimum here. We're not going to go find it, but that's what that graph is. So when are we greater than 0? This is a tough one. I would not ask you this because you need to know those values. So I would not ask you that at this level. All right, so now we're going to sketch piecewise, set it to 21. And when are we greater than or equal to 21? So the sketch, V-shaped up, 8, 9, y-intercept on the other side. So a 0 gets me 16 and 9, 25. If a 0 gets me 25, then so does 16 get me 25. All right, so 21 has to have answers between 0 and 8 because 21 is less than that. So what do we have? We have a function decreasing, then increasing. So the piecewise function. Oh, sorry, Alfred. Alfred Hitchcock. There we go. Y equals. So we're decreasing. So that's -2 x minus 8 plus 9. But I only decrease until I get to 8. Once I'm equal to or greater than 8, going up, going up. So that's +2 x minus 8 plus 9. There's your pieces. Now we're going to use our pieces to set it equal to 21. So -2 x minus 8 plus 9 equals 21. I'll do it twice here. I'll just do it in this space. So take away 9, that's 12. Divide by 2, -6. Add 8, +2, which is a number between 0 and 8. It looks like it's closer here, so that looks like a good answer. Now I'm going to do the positive side, which means that this becomes +6, still subtracting, but dividing by a positive gets me a positive. And now I'm going to add 8 to 6, which is 14. Those answers look good, 2 and 14. They're both 2 units from 0 and 16. And 2 plus 14 is 16 divided by 2 is 8. So we have 2 answers that look good. One of them was 2. The other was 14. And now I can figure out what I'm bigger than 21. And that obviously 25 is, right? So it's going to be true, false, true if you check out some numbers. All right, let's check out a number where it's not true. 8. If I put 8 in, I know I get 9. And 9 is not bigger than 21. That's why false. And these are linear branches, so you're going to get sign changes. There are 2 ways to write this sinusoid. Again, we're working, I think, with the easier conceptualization. That y value is 1 in the unit circle. And from here to here is pi over 2 units. So I want 1530 to act like pi over 2. And I want 1670 to change by 2 pi. I want my new y value to be 2 pi bigger than pi over 2, because once around brings me back to a max. All right, so excuse me, I just butchered that because I'm doing 1 period. I want 2 pi, so I want 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, I've got to change. My change in y is 5 pi, and my change in x is what is it, 140? So I'm going to have a 140 to 5 pi ratio in my algorithm. And here are the 2 ways to write this. And some of you have already had this down and doing it. Probably already did the problem by now. So what am I starting with? Midline is where we measure sinusoids from. And what's between 10 and 20, 15? Oh, I got to change this because the amplitude is going to be, I guess it's fine, 15. And how am I getting from a height of 15 to 20? I need an amplitude of 5. I'm going to do sine function first. We've already done a chunk of it where we have 5 pi over 140. That's our kind of slope for the changing angles, circumference, right? The angles on the circumference become our x-axis. So it's just a linear function. 1530, so x minus 1530. Trying so you can see all of this. And that's going to be plus pi over 2. So you should put the numbers in to see how they work. If you put 1530 in, you can see the cancellation. You get pi over 2. The sine of pi over 2 is 1. All right? 1 times 5 is 5 plus 15. 5 pi later, well, there's 1 pi, 2, 3, 4, 5. Now I'm at the bottom of the circle. All right? And if I convert to that location, well, now I got a minimum. That's where I'm at. All right, and if you wanted to write it more succinctly, cosine is what I meant to write. Cosine of 5 pi over 140, x minus 1530, and you're done. And the cosine has a max, remember, at 0, right? Its min, it's pi over 2. At pi over 2, it's equal to 0, right? Because there is no width. This x distance at 0 is 1. This x distance, when we're pointing straight up, is 0. So, cosine and sine functions do the same thing. They're just 90 degrees apart. You're still drawing triangles, and you're getting numbers between 1 and negative. All right, so we're going to organically find the ln of 25 halves. I've asked you, I'm just putting the negative exponents down, right? Negatives reciprocate. So e to the negative 1.6, roughly 1/5, which means that e to the 1.6 is 5. You do that in a calculator and you're pretty close to 5. All right, that's how we're going to get a feel for this. So, there's an eraser. So organically, I'll make sure, one of these days I'm going to put this in my pocket before I start making these things. All right, so organically means I'm going to write 25 over 2 in E notation. 25 over 2 in E notation is 5 squared divided by 2, and I can turn the number 5 into e to the 1.6. And that is getting squared, and that's being divided by, well, e to the negative 0.7 is 1/2. Excuse me. So e to the 0.7 is 2. And so this 25 halves becomes the ln of e to the 3.2 divided by, why don't I just put it here, e to 0.7. Right, now I've converted that into e notation, and this is looking for the exponential activity. And the exponential activity appears to be 3 times 2 minus 0.7. No, that's not 3. Oh, I always get tired. Okay, so this is actually 2 times 1.6 minus 0.7. Okay, finally on the right page. Now, what's another name for 1.6? That's the ln of 5. Minus 0.7 is the ln of 2. And this doubling occurred when that 2 was inside the parentheses. Okay? So if I was doing this problem to get here from the ln of 25 halves, I know division has some subtraction to it. So step 1, that would be true because that's what we did. Step 2, we wrote it like that. And that becomes the same thing as multiplication by 2 ln of 5 because the exponential activity is being doubled when we put it in e notation. And now I can see 2 times 1.6 minus 0.7 appear without having to do it organically. But I think this is an essential step. Most of you are already, half of you are doing this already. And hopefully the other half will start doing this so that you have a shot at understanding what the rules of logarithms are. Okay, what do we got next? Graphing a log. We want this to become perfunctory. So how do you graph logarithms? You set the parentheses to 0. You set the parentheses to 1. You set the parentheses to the base of the log. So if I make this 0, I am trying to make sure I know what log base 5 of 0 is. If I put in a 4, I get log base 5 of 1. And if I put in an 8, I get log base 5 of 5. That one I'm not worried about. The other two I am. Yeah, that's where you're going to get hung up. So I'm just going to make a 0 by putting 3 in and it's undefined. I know that the positive multiplier and a base bigger than 1, the inverse of growth. If I put a 4 in there, I get log 1, which I know is 0. 0 times anything is 0. I actually get a 4 out. That will happen every single time. You make the parentheses 0, you can hide that, and you get the constant. The next, if you can make the parentheses the base, you're going to get 2 plus 4 is 6 without even looking. But let's put an 8 in. 8 minus 3 is 5. What's log base 5 of 5? 1. 1 times 2 is 2 plus 4 is 6. And so now we are done graphing a log. Okay, what's the domain? X's have to be bigger than 3. We said that earlier in the video. This has to be positive, or you can't perform the calculation. What's the range? Going to negative infinity all the way up to positive infinity. What's a number that helps us see negative infinity? Why don't you drop in 3 over 125? What's going to happen? The 3's are going to cancel. And you are going to take the log base 5 of 1 over 125. We've been practicing that for a long time now. That's negative 3 times 2 plus 4 gets us negative 2. Where is 3 and 1 1/25? Pretty close to 3. Maybe we're here. 3 and 1 over 125 gets us negative 2. Okay, because you got to get a better understanding of what's going on here. So we got to work with some numbers. Last problem. All right, so how do we go about getting these types of problems correct? Well, you gotta know your 30, 60, 90s, your 45, 45, 90s, and your 60, 30, 90s. That's a degree of 60. This one over here is 30 on the left. Okay, gotta know those. All right, so draw a circle. Not the worst circle I've ever drawn. Line across. I'm gonna break it up. Pi is 180 degrees, so I'm gonna break it up into 3 parts. Good drawings get good answers. If there's 3 in the numerator, there's 3 in the denominator. Pretty good drawing, which means I have 6 pi over 3 once around, 12 pi over 3 twice around. Cut to the chase, 24 pi over 3, the same as 8 pi, which is 4 times around. And I gotta get to 25. That's this triangle. I can see I have 60 degrees because 180 divided by 3, I have 60 degrees, which means that's root 3 over 2, that's a half, and that's 1. I'm looking for the cosine. My answer is a half. Okay, so that's our practice for the day. And tomorrow, same problems, 5 days in a row. And I suggest that in that amount of time, I don't know how long it took me to do this. I'll know in a minute. I'm gonna guess 20 minutes, 15 maybe. We do that 15 minutes a day, 5 days in a row, and you've learned a lot of math. And you're well on your way to building and strengthening your foundation with these problems.